Hello, welcome to Code Zero, a series of videos that explores the world of code. My name is Pragma. Have a great time learning about code.
Hello, it's Dr. Abstract here. Thanks for that intro, Pragma. In this Code Zero, we're going to do something a little bit different. I know you want to get back to coding, and so do I. But in this Code Zero, we're going to take a look at the very essence of code, and that is hierarchy and organization. As a matter of fact, that is the very essence of life, we could put it. From chaos comes organization. So let's go to the Zim site now at zimjs.com, click, and if we go into the About section, hey, there's Dr. Abstract, woohoo! And we scroll down here, this is an intro to Zim and some of the features and the types of applications that we can make. Archives of old sites, reviews. The Zim team, the animator Antonio. Hey, and there's that founder Dan Zen guy. Some friends of Zim. And at the very bottom is a section that we're working on right now called Philosophy. And if we click the Creativity Framework, which you'll find here, here we are. And so this is at creativityframework.com. And it's the mechanics of creativity that underlie many creative exercises, brainstorming, mind maps, etc. by this guy, Dan Zen. Have you heard of him? And it looks like, judging from what people have said about him, that perhaps he is fairly creative. Yes. All right, so on we go. And there's more, 50 more as a matter of fact. So let's go to the framework now. Here it is, the Creativity Framework. And right away, if we hit this arrow right here, or the arrow to the right, right away we're getting started. We've got one thing, this big box, that's the Creativity Framework, and then it divides into two parts, the context and the content. And here it is again, one thing that divides into two things. So that's called mappings or isomorphisms, and we're going to see more of those. Now there's two parts, context and content. In the first part, the context, we're going to describe the structure of the framework. And in part 2, content, we'll look at how to use the framework. And now, for coding, all I'm going to do is introduce you to the context, some of the terminology of hierarchy, so that we can code better. When it comes to creativity, it would be great if you looked at the content, actually how to use the framework to be creative as well. Now, we're in this world of information, for instance, and you may have heard of mediums or medium. And a medium just sits between, there's hot, cold, and medium. A spiritual medium sits between the living and the dead. Ooh, that's what we've going on here. Hey, do you recognize that node globe? That's called a node globe. We clicked on that earlier. And there's that Dan Zen guy, and he's contacting, who knows, in the medium somewhere. And paint and clay is a medium that artists work in, and so context is a medium in which we can create content. And here's this guy, Marshall McLuhan. He was famous for saying, the medium is the message. And if you want to get into all this interactive media stuff, Marshall McLuhan would be a fun fellow to look up. He was a Canadian guru of the information age. And he confused a lot of people, saying the medium is the message. I suppose if he meant that the medium is very important, or it's important to know about the medium, then I fully believe in that. As a matter of fact, the ad for the Creativity Framework is, it's not what's outside the box that's important. It's not what's inside the box that's important. It is what is the box. And that's what we're going to show you here. Okay, so moving along. A hierarchy, or a tree, is the basic form of organization. And the strength of this framework is we're going to show you the mapping of hierarchies, the fact that they're everywhere. So let's take a look at the terminology of a hierarchy first. All right, well, here's a classic hierarchy, and this is everything, and of everything there's animals and there's plants. There's also many other things. And of animals there's cats and dogs, etc. And plants there's trees, bushes, and flowers. Okay. Now this thing right here is called a node. We can have a node over there too, and a node here, and a node there. And as a matter of fact, this node right here is node 0. It's everything, the universe, because we start counting at 0. So there's the node. Now here it is. Here's what context and content is. Context is what's up above the node. Content is what's down below the node. Very, very simple. Until you start getting philosophical and saying that context is what's happened. And that's how we think of it in English. The context is, hey, what happened to get to this point? Well, the content is what's in the future. And as a matter of fact, as we make content, it becomes context for other people. Fascinating. Okay, now over here we've got common words that we use all the time, including words that we use in coding. So that's why it's good to know what these words are, because they're quite simple, despite the fact that they sometimes sound complicated. So let's take a look at some of them then. First of all, we've introduced another node here, and that's a sibling, or a brother or sister, but it doesn't have a sex. So that's a sibling. Okay, and siblings have parents, so a parent node, and they have children, and that goes down. We can also say next to is para, as in a paradigm shift. Now that's actually, or parallel lines, etc. That's actually part of the reason why this is called the creativity framework. There's a famous thing in creativity called the paradigm shift, and everybody's looking for that. Well, that can explain it. It just means next to, and we'll talk more about that. So we've got parents up above, children down below. Also up above is super, like Superman, or a superclass in code. And we've also got subclasses in code, and that's down below, like a submarine. When we go up, if you take a look, if we go up, we're joining things. So if we have cats and dogs, cats and dogs, and we go up, we're joining those together to make all of the animals. Well, there'd be more animals. Okay, so going up joins things, as you can see, and going down splits things apart. Now there's another word for splitting. That is the aspect of something. Oh, what are its aspects? That just means you're splitting. As you go up, you gain a perspective of things. You can look down at all these things. Oh my goodness, I have a perspective. Over here in these words in brown, we've got, if you split things apart, you are analyzing. All right, analyzing just means split things apart. And if you join them together, you're synthesizing, like synthesizing notes together, or synthesizing in chemistry. All right, big words, but it just means to join and split. Now as we go up, we get more general. We become more general. And as we go down, we are more specific. We specify things. Is that good? Yeah! We also have branches. These are called branches, and we have endnodes. Alrighty. So when we organize or group, nest, categorize, or classify, those are all the same. Group, nest, categorize, classify, organize. We split and we join things. And this process is represented by hierarchy. So below we're going to map the hierarchies across many vital organization systems, starting with one that maybe you saw in the morning. Drawers, okay? And here's the sock drawer and the underwear drawer, so you want to keep those separate, or maybe you put them together. You want to keep them separate from your shirts anyway. I know that. That is for sure. And those also might be called sections or boxes. Now, if you just take the top line and the bottom line of each of those, not the sidelines. So we're erasing the sidelines. So here's the top line of this one, and there's the bottom line of that one. Do you get it? And there's that box, and that box. So if you take those and you just put angle brackets around them, that is the format of XML or HTML. HTML might be considered a special form of XML. As a matter of fact, XHTML is specifically the form of XML. But in general, it's putting tags around that organization. So really, the whole internet, all those web pages that we see built on a hierarchy, a document hierarchy called the DOM, Document Object Model. If you just take the top lines, and we keep the indenting, so we're just taking the top line now. You see this is one big thing here that holds two things. This is one thing, that's another thing, two things. And then that holds two things and holds three things. Okay, so one big thing that holds two things. This one holds two things, and the second one holds three things. Okay, and same within there. But anyway, those look like indented paragraphs. Oh, what do you know? Like a table of contents or something like that. If we added bullets to that, that's how we organized back in grade school. Maybe you're in grade school still. Wow, it'd be nice if somebody showed me this in grade school. But they did not. As a matter of fact, when I was a patent agent later, and we specifically had subclaims, and it was taking inventions and the most complicated legal document, and all these really, really smart people were training me on how to become a patent agent, and nobody ever showed me this. Too bad. It would have been so much easier. Okay, so if we take a line and we draw it down like that and join these two bits, and we draw a line down and join these guys, that looks like a directory structure, right? Remember, I don't know if you ever used Windows, but that's a directory tree with files and folders, and what it really means is our files and folders on our system are just a way to hold a hierarchy. We're nesting, we're putting things inside. Obviously, if they're folders, we put things inside them. So, what did we do to get to this part? That's right. We just took this thing and we spun it around, we rotated it. And then we're taking the sidelines with the corners. And if you've got these little corners on here, that's the same as an array, or a multi-dimensional array, we call it. So arrays within arrays. We've got two arrays sitting inside of another array, and three arrays sitting inside of this array, and then these two arrays are sitting inside of the outer array. So back in the day, when XML was just coming in, I was at a party going and, party in the kitchen sort of saying, why do we need XML? We've got multi-dimensional arrays to store our hierarchies. Is that what you say at parties too? I hope so. All right, so on we go. Now, here, this is neat. If you take a line right from the middle of the outer box and bring it over to the middle of the inner box and the middle of that one, it's a line that goes over to the middle of the one box and a line that goes over to the middle of the other. And then you continue that line down through there to the middle of the boxes in between, or inside there. Ba-doop, ba-doop, and to the boxes of these three. Ba-doop, ba-doop, ba-doop. And you get this direct mapping. This is the same information as that, just in a different way. Those are called isomorphisms. Ooh, the isomorphisms of hierarchy. And if you look carefully around, and probably in that philosophy section, I'll show you the big art piece that Inventor Dan Zen created and put up on the isomorphisms of hierarchy, and that was made with used crazy carpets. Okay, so great, we use that hierarchy tree all the time for things, including to map out object-oriented programming OOP, like we put our classes and subclasses in it sometimes. Okay, now if we take letters and put them on the bottom, A, B, C, D, E on the leaf nodes, and then we put these little characters that are dividers that are on levels, so carat, carat, carat on these levels and a tilde on that level, or a hat, 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 and a squiggle, those are called delimiters. They delimit, they split. And then we can get A, carat, B, tilde, C, carat, D, carat, E. And from this, which is in formation, it's in a line information, like marching along in a line. It is information. That's what information is. Delimiters might be, in the language, they're things like periods, they're punctuations, periods, commas, or spaces between the words. Those are a different level of delimiter. And paragraphs, a different level of delimiter. Pages, etc. So you also call that serialized data or code. That's code. And we can break that code up or reconstruct this hierarchy from that code. Isn't that cool? Okay. Now, this is our friendly hierarchy here, where we've turned this one upside down and we made it curly or smooth or rounded or whatever you want to call it, not angular like this one. Ooh. So it's more natural, more organic, like a tree. And we keep our delimiters there in the same, so that main split there, and then carats for the other splits. Okay, branches and leaves. So we flipped the hierarchy and we made it look like a tree. Now, if we were looking up the trunk of the tree, imagine standing at the bottom right in the tree and looking up the trunk, you would see this big round trunk, and then the branches split into two. So there'd be a branch on this side and a branch on that side. And then it would split into 3 over here, and it would split over into 2 there. So it's like looking right up the trunk. Doesn't that look like nests? Oh, cute. Or cells. And a group of cells called an organ or an organelle. Neat, huh? And what are we doing? We're doing organization. We are organizing. Cool. Now, if you don't really care what A, B, C, D, E are, but you only want the structure of this cell, then you can get it by saying carat, tilde, carat, 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 tilde, carat, carat. From this, I can rebuild this cellular structure. And code that builds cellular structure is called DNA. Ooh, isn't that cool? So DNA just has chemical delimiters in it, and it has the structures to rebuild cells. All right, now if we start with node 0 here in the middle, there, that's my arrow to go to the next page. If we start with node 0 here in the middle and put our hierarchy coming out the sides like that, we've still got the same thing. We've got one thing that splits into 2 things, this splits into 2 things, and that splits into 3 things. And this is the format of a mind map. I don't know how they got, that's just a radial hierarchy, but I guess you can also call it a mind map. But it's a radial hierarchy. It's going out in a radius, much like that node globe we showed earlier. And if we had a lot of these, it's neat, and it's called the mind map because the brain, the mind itself, is made up of a bunch of neurons. And at the ends of the neurons are these dendrite trees, and that would be all in 3D. So we've got a brain in 3D. And it's Inventor Dan Zen's philosophy, his theory, that perhaps as we forgot to mention in the last slide, hierarchies only have a node 0, one parent, so they all keep going up like that to one place. And that one place could be, in the mind, consciousness. We feel like we are one thing in our mind. That's not to say that physically there is a single place in the brain that all of this stuff reports to. That's not how it works for sure. We know what the brain looks like. But at any one given time, it is Inventor Dan Zen's philosophy, is thinking that these report to one place at any given time, and that moves around, and that thing that's moving around is consciousness. Cool. So that is the isomorphisms of hierarchy. Now, in the creativity framework, there's exercises that were built with Zim. So these exercises were built with Zim, where we try and place things. So a perspective, do you remember where that was? I thought it was over here somewhere. I'm going to try a node. Oh yeah, so the node now snaps in. More general is up above. Parents were up above too, so that's parents. Oh, perspective is there. Synthesize. Do you remember, was that joining or was it splitting? So this would be splitting. I think it was joining. Yes, it is. And the node, can you remember which one's past and which one's present? Is this the past or is that the past? That's right, the context is the past, which goes in there somewhere. Probably the word context is somewhere. Well, we don't need to do all of these. Now, the neat thing about this is there is a multi-user version. Well, first of all, there's a hint, so you can sort of see the size of these boxes and go, oh yeah, that fits there, and sub is down below. Oh, it fits there. Okay, so we'll get rid of the hint. But there's a multi-user version. So if you're doing a workshop on this, or if you've got other people around, then you can work on this together and drag these. And that's done with Zim socket. So all of this was built with Zim. The second one too is also built with Zim, where you organize the different types of data that we have. For instance, that's a really simple one with two things inside of one thing. And so is that, and so is this, and so is that, and so is that, but not this one. So you have to figure out where those ones are. For instance, this one has 2 and 3. Let's put it there. This one has 2 and 3. That's in a good place. This one's 2 and 3. Good. That one's got, that's not 2 and 3. This one's not, etc. What about that one? Nope, that's 3 things, just like this one. So you organize those, and once you organize them, they you win. And again, a multi-user there. All right. So the meaning, the structure of a hierarchy is pretty easy. You know, that was pretty easy to follow. But it's tricky to divide up the meaning or semantics, in part because there's 2 ways, ands and ors, plus a combination of ands and ors. Okay, so the first one's called composition. It's physical, it's real. The shelf has books and vases. Those are real things that are there. Books are made up of cover and a page. So it's the parts of the composition of something. Pages have numbers, titles, and paragraphs. So we say pages have these things. Those are properties of pages. Okay, and those are ands, numbers and titles and paragraphs. So that's the first one. Second one is classification or ors. So these are types of things. So not parts of things, but types of things. So of everything, there are these things called publications. And their type of publication, you could have a book, or you could have a magazine, or you could have a whatever. And types of books, you might have a sports book, or a romance book, or a sci-fi book. And a type of sports books, or type of sports, I guess, sports would be hockey, soccer, and tennis. Okay, so you have one of those things. So you have hockey, or you have soccer, or you have tennis. Now it's a little tricky because you can say that hockey, soccer, and tennis, hockey and soccer and tennis make up sports. And the theory behind that maybe is composition is real. Classification is just a structure we put on top. But composition lives even within classification, the act of classifying. Yeah, that is the theory. And then you can have a combination. So Professor Y, or Professor Y. There's this other guy, Professor Y, in the future, but we'll leave him alone. Inventor Dan Zen often says that he was writing in sketchbooks for 10 years, writing these hierarchies before he realized that there were 2 types and that he was making a mix of all of them. And that's why things became a little bit complex. Flexibility. The framework uses hierarchies extensively, so it's important to realize how infinitely flexible hierarchies can be. One of the problems with hierarchies is that people associate them with their work, and they think of their boss as boss and boss, and most people are down at the bottom of the hierarchy. It's almost like that old feudal system where, you know, all these peasants working away, and then you've got the lords up here and the kings and queens, and you know, so that's what a lot of people think of with hierarchy. So we'd like to show you that that is really not the case. I mean, it might be like that, but there's other ways to look at it. Okay, so first of all, and they think that hierarchies are rigid. And so let's just show how flexible hierarchies are. Composition, in reality, of everything. There's Dan's house. There's Dan's bedroom and Dan's workshop. And in the bedroom, Dan may be. But over time, so this is your hierarchy, and is that very flexible? You know, this is the old common composition hierarchy where you've got a bedroom in a house, in a city, in a country, in a, what's next? The countries in a continent, on a world, in a solar system, in a galaxy cluster, in a universe, finally, yay. So classic composition, and continues on down as well. But anyway, in time, that can change. So Dan was in the bedroom, part of the bedroom, but now over time, he's moved to be part of the workshop. And along with that came Dan's head and eyes and ears and all this other composition as well, moved and changed along. So obviously we have composition, but compositions are changing all of the time. Okay, so it's not very rigid, this nesting, this hierarchy. Okay, otherwise everything would be frozen. Classification is even more wonderful, I think. So this is more conceptual, but of everything, we have inventors. And we have Dan right there under an inventor. And there is inventors who are male. And hey, there's Dan again under inventors who are male. And then there's inventors who are male who live in Hamilton. And there's Dan again. Now there's, of everything, there's males. And there's Dan there. And here's a neat one. Of everything, there's Dan. So you are directly classified under node 0, under the universe. You're at one with the universe. Does that sound familiar? And this just shows it so clearly. So at one with the universe. And this guy Einstein, he was neat, huh? He said, everything's relative. So it very well may be that everything can be classified under Dan. Certainly in the distance away from Dan, for instance. Everything in the universe is classified under Dan in that manner. It's a matter of context. So in writing, you can pick as you go, and the picking is called permutations, what you're picking from. And then as soon as you make a choice, they become combinations. So you've got Dan, and he's riding. No, he's painting. No, he's laughing. Yes, he is riding. And it's a yellow. No, it's a green. So this is composition going down and classification, or permutations going across. Okay? Cool. And then there's exercises on that. Now these exercises to break things into classification and composition is exactly what skills you need to make custom classes when you're coding. So as this is code 0 where we're starting from the beginning, but as you progress and start making your own custom classes, please come back here and try these exercises. And that will help you be able to classify when you need to and compose when you need to. Because really code, that's what code is. If you take a look at it, it's a composition, a bunch of things, a bunch of objects, and those objects are made with classification. Yet in those objects is a bunch of composition again. And of those, certain things are made with classification. So it's just a combination of those two things, and that's what code is. Ba-doop. Flexibility, and we end our context, and there's a little exercise that's fun. You get a tree like that, so you make a tree. You put the letters around the tree, so that's starting from the innermost curl here, A, B, C, D, E, F, G, H. And then you can put the delimiters. You split, one splits here, the next level splits here and here, the next level splits on the pluses there, and then there's a final one that splits there. And then your exercise is to say what the code is for that tree. So you can encode that tree and indeed only use the delimiters if you want. And then flip it around where you're given another one that you can try, so you can try that. And then this one is the reverse. So you're given the code, can you make a tree from it? And there's the tree from it. Wonderful. Now this is the second part, the content. The first part was the context. So it's the first part that we really wanted to look at. This second part goes on to explain these boxes and creativity and these famous phrases such as outside the box, lateral thinking, paradigm shift, and mental leap. They are all the same thing. So outside the box just means outside the box, and you take a look around at your alternatives. How about that? Lateral thinking means we map it to a different view here, the hierarchy view, same as the boxes. Lateral thinking just means go to the side, which is the same as outside the box. What do you know? Paradigm shift is a shift. What do you know? Mental leap is like a leap this way. So all those things use meta, where we go up and next to. Basically, it's finding a sibling, an alternative. What do you know? And there's more and more and more exercises and so forth, and then working out how that all works. And that's the creativity framework. But you know, I've kept you here for a long time, haven't I? And so we will say goodbye from zimjs.com. We were taking a look at the creativity framework to see some of the definitions of the types of things that we're using when we code. Pragma, by the way, knows that backwards and forwards. And now she's going into molecular biology and genetics. Cool. You guys have a great day. Ciao from both Dr. Abstract and Pragma.